So to get started, we're going to run through a brief introduction to EXALEAD OnePart and the business problem that it solves or attempts to solve. And then we'll go through and I'll hand it over to Pete and he'll do a brief technical presentation of the software itself. And then as I mentioned, we'll have some time at the end for Q&A. So EXALEAD OnePart is really designed to help companies eliminate the problem of duplicate part proliferation. Well, that's a mouthful. And many times when we talk to customers, there's a desire to reduce part numbers because part numbers cost money. And what they really mean to say is that new parts or duplicate parts cost money. And depending on the type of part and how it's manufactured and its use within the enterprise, that cost for carrying or owning that part can vary quite widely. And there are many consultancies, and they've done evaluations, and the range goes from $1,000 up to, in this example from the Aberdeen Group, $23,000. So the idea is, how do we help designers and engineers find and reuse existing parts as opposed to recreating parts? So when you're looking for new parts, depending on which consulting study you read, engineers and designers can spend anywhere from 1/3 of their time to up to 40% of their time looking for information, and specifically looking for work that they've done before. If you don't find the work that you're looking for, what you end up doing is, in the sake of expediency, as a designer or engineer, you may end up making a new design, a new duplicate, because it's faster than trying to find the one that you had made before. And in many large enterprises, this can lead to a great amount of part duplication. And the parts can be essentially identical from a geometry standpoint, have similar metadata, but have different part numbers. So the idea is to help reduce the costs that are associated with this, because when you have too many, or if you have duplicate parts, that is wasted effort because you've taken time to create that part again. The new part may or may not be better than the old part, so it may not be suitable. You may have a bad design that's out there and you don't want to use it. You may have a good design that you do want to use, but you don't know which one that you're using. And of course, it affects your time to market, and you can't be as agile and responsive to developing and launching your products as you wish. And then, of course, there are other issues with inventory carrying costs and overhead in the ERP system and manufacturing operations for carrying that extra duplication. So if you reuse parts, that tends to indicate that it's a good thing to do. If you can save that 30% of time looking for parts and find the part that you want to use, not only do you save the time from a productivity and engineering, but you also save a lot of those downstream costs related to the manufacturing, tooling, and inventorying of those duplicate parts. So what if we could use a tool that's going to help us find duplicate parts so that we could reuse them, or at least minimize the creation of new things? And that's really what EXALEAD OnePart is intended to do. It's intended to give engineers and designers and other interested parties within the enterprise the ability to search for new or common parts across multiple CAD authoring tools, multiple data stores, wherever those may be, other information that may be attached to the parts, as well as information contained in general documentation. So it's not necessarily just looking for the geometry, but it's also looking for all the related documents that could be associated with that geometry. And then the key differentiator is giving you, as the user, the ability to compare and essentially shop for the differences between the results that you see, and we'll show you that in our presentation, because being able to compare and contrast the data elements of those common parts is going to help you pick the right one that you want to use. So the approach is essentially, looking for a part, I can't find it, so I'll go ahead and spend, 30 minutes or whatever it takes to model up a new one, pull a part number, put it in the PDM system and release it. Or, use a tool that I can find the part that I do want to reuse and do that in a very quick and hopefully close to about a minute, so that then you can go and use that part and therefore save all that lovely money. So what OnePart is it's essentially it's a web application that is intended to be easy to use. So you'll get a Google search experience, based on the EXALEAD CloudView platform, which is a proprietary search algorithm that's used to build a search-based application like OnePart. You install it. It's a server-side application. You point it to your data sources, and it will index those 2D and 3D assets as well as any associated documentation, and it'll look through all those variety of CAD formats, and it's not really too concerned about where that data resides as long as you can connect to it from an IT standpoint. And then it'll take that index and bring those results to the user in the search dialog. So the key capabilities that OnePart brings to the designer engineer is that ability to do not only metadata searching, but 3D shape searching, as well as searching on key modeling features that have been interrogated throughout the CAD model, independent of which CAD format they were in. And because of its semantic capabilities, it can auto-suggest search capabilities as well as handle some minor misspellings of words. And most critically, as I mentioned earlier, it can give you that side-to-side comparison so that you can quickly take the result set, narrow it down, identify the part you wish to use, and begin using it. So that's what I had for an introduction. So we'll hand it over to Pete, and he can go in and show you the technical presentation. So give us a moment here. I'll make Pete our presenter. Are you ready? All right. Take it away, Pete.
Okay, so I'm going to be showing you from a user's side how you would use EXALEAD OnePart. So I'm going to open up an assembly. It's a conveyor assembly that I'm working on, and I'm going to search my company's data for a bearing that I can use on this conveyor. So again, EXALEAD is a web-based application, so you simply publish a URL to your users, and that's how they access the software. There's no installation, hence no upgrade needed later on. It's just a web address that you go to. There is a login, so it's using security based on the different systems that you're connecting to. So my user has to have the proper rights to view all the files. As soon as I log in, I'm in EXALEAD OnePart, and I have basically my search field. There's one field to type in, and that's what you're going to search on. There's a few other things on the home page. There's a popular list of items that are popular, new items that have been added, as well as a discovery. So we'll get right into a search, and I'm going to be looking for a flange bearing, and I hit enter, and you can see right away I get 21 results. I can page down through all the different results. You can see that I'm getting PDFs, I'm getting SolidWorks parts, I'm getting some other PDFs that have drawings. One thing you'll notice, I've typed in flange bearing. If I type in bearing flange, I'll get the exact same 21 results. If I type in flange bearing but misspell it, I'll get the exact same 21 results. So it's flexible in that search results because it knows that I'm what I'm looking for, essentially. So on the results page, on the left-hand column, I have the W's. I have when, so it's telling me when these files were created, by who they were created, and this is all based on metadata that it's indexing inside of the files. What is what type of files it's finding, what families it's finding, are they components, are they documents, colors. Where is it finding the files, because I can search many different sources for files, including network drives, PDM systems, SharePoint, all sorts of different inputs. There's different tags in here that users can define for things that are preferred or obsolete. And then the how gets into kind of how is that part made, what's it made of. So different features that it has, different component sizes, and then under more, I can actually narrow that search even further given different, so bounding box sizes, mass, volume, definition, revision, name, all sorts of different fields there. Okay. There's different ways that you can also look at the results of your search. One of the big pages that you can look at are called analytics. So when I click on that, this is going to give me information about the files that I've found. It's going to show me a creation timeline, modification timeline, who created these files, and some pie charts about what extensions were returned, what families are they in, what types, things about the materials that are used to make these, component mass, component size. I can also view this in the results tab, so it gives me more of a column feel. The nice thing about the column set here is that I can export this to a comma delimited file, so I export it directly into Excel for further manipulation. I'll go back to my results list. So from here I can start to explore the results from my search. I can click on a file. Within the file I have all the attributes for that file. What material is assigned to it, what is its mass, who created it, when they created it. Then at the bottom you start to get into things like 3D similarity. So it's identified these 8 files as being similar in size, but you also notice it identified 3 as being truly identical. So now we can get into the comparison. So we use these stars here to select and compare certain files. So I'll select these 3 files and I'll throw in one that I know isn't identical. That'll go to the star to go to the comparison page. And it's like you would for any other kind of web page. It's going to start to compare and show me the differences in them. So between the first 3, the differences are the file name. There's attributes in here for part number, for description, So those are different. But then at the bottom we start to get into the physical differences between the files. So the first three are strictly identical to the reference. And right now this is my reference file. I can change what my reference is by choosing this button. And now I've set that as my reference file and comparing the others to that. So these three are true identical parts to that file, whereas this last one has differences in the size, in the X, Y, and Z, differences in density, in mass, very similar in volume though. So I'll remove that from my selection because I've identified that as not being significant. Now if I go back to my original one, so I'm just a click away from this list. So I've looked at these other ones. I'm going to trash that selection. I'm going to start a new selection. I want to see, why are these other files so similar? What makes them similar? So I'll make a new selection set and start a compare. And now I can look at these and I can say, okay, well, they have different names. They have part numbers that are similar but have some differences. And I can see that the sizes are also different, and it's giving me a percentage of similarity at the bottom. So it naturally grades them as closest on down. So I'm going to click on this one to see what it looks like, get some more detail on its part, where it's found right now. And if I go into the related documents, so it's also finding documents that it thinks are related to here based on information that it's finding in the file. And here I can actually find a drawing. So here is a PDF, like a cut sheet from a catalog, and I can open it. So I can actually zoom in and I can see that this is a bearing that's going to meet my needs because it has the right shaft diameter on the collar. It has the load capacity that I need. So I'm going to then use this bearing in my assembly. So once I get back to my page for that, I can just say open. It'll open in SOLIDWORKS. I can then tile. I'm going to zoom in on my shaft here, drag and drop my bearing into place. It has some features on it that allow me to mate it in place right off the bat. So there, I found the bearing I needed, I dragged it into my assembly, and I'm using it. All right, if we go back to OnePart, the 3D wheel here is kind of a home button, so that takes me back to the home page for this. You can see my selection is still active. It remembers the selection that I made, so I can go right back into that selection, go into that comparison. I can also share this selection with a coworker by going up to the share button, and it produces just a simple URL that I can then copy and email to a colleague. He clicks on that email, logs into the system, and he'll get to this exact same page instantly. I don't have to tell him what I searched for. I can just show him here. This is what I searched for. These are the results. These are the comparisons. What do you think? This is the one that I'm going to go with. Okay. So again, back on the home page, we can clear that selection, we can use it, we can save it for later, we can look at things that are more popular in use, we can look at things that have been newly added to the index. Again, it's a real-time index, so you schedule the index for how often it's searching all your data stores for new files that are added. Another thing that I can do is I can say search for file types. So by default, it's all types are going to be in my results. I can narrow that to just SOLIDWORKS assemblies and just hit enter, and it'll find me all the SOLIDWORKS assemblies in my index. So from here I can scroll down, find an assembly, click on it. Here it's going to show me, because it's an assembly, it's going to show me all the children that are in the assembly. And if the icons show up, I know that it's finding the references as is. If you have a lot of data that has broken references, you can actually change the scheme in which it finds the mappings. And you can tell it to, because EXALEAD will know about the children, but it may not find them where they were last saved. Well, you can change the way the assembly mapping is done, and it will actually go and find them in places that it's moved to. And you can also traverse up and down the tree. So I can click on a child, I can see its details, I can see where it's used, I can click on a parent, and I can click on go up a level. So I'm basically stepping up and down the tree here and get all the way up to the top level parent that this assembly was used in. All with simple search terms, all done by indexing. So that is the user experience for EXALEAD OnePart. So I'll turn it back over to Eric.
Okay, thank you, Pete. So essentially, EXALEAD OnePart is intended to help you save time and increase your responsiveness to getting work done by helping you reuse work that you've done in the past or that your company has done in the past. So by reusing known functional parts that have been released and are in production, that hopefully saves time, it improves your quality, and will allow you to lower those costs related to manufacturing and inventorying those parts as you move downstream. So we have a couple minutes left, and we can go into Q&A here. We did have one question, which was how long does a system take to set up? And a lot of that will depend on the size of the data stores and the number of files that you're indexing. But essentially, when you determine that you would like to index your data, you have to pick the variety or the various places that it needs to search, and then the application is loaded and configured and security is set up, and then you index the parts, and that process is on the OnePart server, and it points at those data stores, creates what OnePart calls the corpus, which is essentially the index that's used by the search application. And that can take anywhere from a few minutes to several hours, depending on how many parts you're pulling. We got one more question here. The indexing is set up. So the question is, how is the indexing set up and how is it pulling the metadata? The indexing is configured through the OnePart administration console, and the metadata is extracted not only from the file contents but also the Windows properties of the files. And then if you have the data in a PDM system, it can also extract PDM-related data as well. And because with SOLIDWORKS data it's looking at the parent-child references, it's getting that by actually interrogating the native SOLIDWORKS files.